talking about domain and range of functions. Previously in the last lesson, we defined a domain as all the possible input values for x in a function. And we defined range as all the possible output values y that we get back. So let's take a look now at a quadratic function. We're going to start getting in some interesting cases. These are all functions that we're going to play around with later on in this course. As we go through algebra, you're going to learn about all types of different functions. But it helps us to understand domain and range when we look at some interesting cases. So here we can see here, let's take a look. We got an equation, we got a table, we got a graph of a quadratic function. It's got an x squared in it. You'll notice there's some different things when we're working with quadratics instead of linears, right? If I look at my x and y values in my table, my x values plug along, -2, -1, 0, 1, 2. But my y values seem to decrease, go from 1 to -2 to -3, but then they start to increase again. I can see this on my graph here as well. My equation, my parabola comes down, it kind of levels off, hits a minimum point, and then starts to increase back again. And then parabolic functions, quadratic functions, they go on and on to the right and to the left. So we got the little arrows there on the ends as well too. And so let's think about this thing. What are all the possible input values x? Well, if I look at all three of these, it would seem to me that my graph is all connected. There's no gaps, there's no weird spaces, and then it goes on and on forever to the right. It goes on and on forever to the left. So looking just at the graph, I would say there's no limit. I can put any positive values, any negative x values. Anything would work for x. And if I look at my equation here, I can think about, okay, what can I put in for x? Is there anything I can square and subtract 3? Is there anything I can't do that to? No, I can square any number I want to. I can square positive numbers, negative numbers, fractions, decimals. I can do all that and subtract 3. So here I'm going to say my domain is all real numbers for this particular quadratic function. I can put anything I want in for x. The range is where we get to kind of some more interesting stuff here. Remember, my range is all the possible output values y. If I look here, I can see I get positive y values 6, 5, 4, 3, 2, 1, but there is a point where I don't get any of these y values down here. My function never seems to go down below this certain point. So I want to be able to describe, hey, my function seems to stop. It works for these particular y values, but I don't get anything back for these particular y values. And in this case, I would say, since it goes from -1 from 1 to 2 to -3, seems to be kind of a key point, and then it starts to increase again. On my table, it seems to me, okay, -3 seems to be the lowest place it'll go. My graph seems to confirm that. I can confirm it on my table because anything I square always turns positive. So no matter what I put in for x, it's always going to turn into a positive number. So the smallest this whole x squared thing will get is if I put 0, because 0 squared is 0. And so then I have 0 minus 3, so -3 is the lowest, smallest y value. So if I combine all that equation, table, graph, I can pull that all together, I would say my range is all real numbers, but there's a caveat to that. Greater than or equal to -3. And there we go. My range has a limitation. It works for a lot of numbers, but not every number. It's only the numbers greater than or equal to -3. All right, so there's a little bit more interesting case of a graph, a function. The domain is all real numbers, but my range has a limit. My range is only all real numbers greater than or equal to -3.